Hello friends, welcome you all IAS with Arihant and everybody very good afternoon. If you are new in this channel, please subscribe the channel, hit the bell icon and share this class who are preparing for the UPSC exam and state PCS exam. Also you can share this class with your friends and those aspirants who are very serious about their UPSC upcoming prelims exam. So here, this book by Arihant, Prelims Possible. This is the series of Arihant book Prelims Possible, which have 300 plus solved paper. If you do not have this book, you must purchase this book for your upcoming state PCS and UPSC exam. This book really has a amazing content and a variety of questions which are majorly come in the exam. Now, what are the features of this book? Why have you purchased this book? Because this book having a chapter-wise division, chapter-wise, topic-wise division, also topical mind map, also topical mind map, 100% error-free explanation, knowledge plus for typical questions, 3500 plus PYQ bullet. If you want to study with a easy manner and in a easy way, you must have this prelims possible series. Now we are going to start our class today is a new chapter, second unit, mechanics. In previous class, we have completed first unit, units and measurement. In this class, we have started a new chapter, mechanics. And what is mechanics? Mechanics is a branch of physics and study. Mechanics is the branch of physics dealing with the study of motion when subjected to forces or displacement and the subsequent effects of the bodies on their environment. So, our number one topic is motion and Newton's law of motion. What is motion? What do you understand by motion? How can you define motion? The change in position of an object with respect to its surroundings in a given interval of time is known as motion. Change the position of object with respect to time is known as motion. Also, motion further divided in the types. In how many types? It is further divided in the three types: one dimensional, two dimensional and three dimensional. So one dimensional is a rectilinear motion. When you were in a class 11th or an 11th standard, when you come in a high school, after high school you comes in a secondary senior secondary school, you have taken subjects like physics, maths, bio. So in the physics we study the first that motion types divided into three parts. Motion types divided into three parts. In linear motion, first one is linear motion, also known as one dimensional motion. Second one is rotatory motion. Second one is rotatory motion. Rotatory motion, also known as circular motion. And the third one is oscillatory motion. Oscillatory motion. Clear? So the one dimensional rectilinear motion. What is linear motion or rectilinear motion? The particles move from one place to another in a straight line is known as one dimensional. Like this, if you are going to point A, from point A to point B in a straight line, it is one dimensional. And we can call it as a linear motion. And what are the examples of linear motion? Like walking on the road, a car on the road, and a truck on the road, having a train on the road, right? So these are the examples of one dimensional. Second, two dimensional. So before we are going to study about two dimensional, you must understand there's given a word here, projectile motion of a body projected at an acute angle from vertical. Example, a bullet fired from a rifle. What is projectile motion? Tell me. Projectile motion is a motion of an object thrown or projected into the air, subject to only the acceleration into the air, subject only the acceleration of gravity. The object is called as projectile and its path also called as trajectory. So let's discuss about or understand what is projectile motion. What is projectile motion? So we are going to understand this projectile motion by graph. So this is the projectile motion. How can we going to study this? Take it as a any particle. If you thrown any particle in a vertical motion or in a vertical direction, it comes automatically to cover the horizontal part on the earth. All right. So there's a 0. This position is origin 0. We thrown one particle and it comes on the earth like this. This is the pathway of projectile motion, and this the pathway is called as also trajectory. Trajectory. Clear? So O position of or point of projection. It is point of projection. Point of projection. So here this is y-axis, this is x-axis. When particles comes in this position, its initial velocity ux in the x-axis is equal to cos theta, is equal to cos theta, u cos theta, u cos theta. And in this way, on the y-axis, uy is equal to u sin theta. The particle is u sin theta. When this particle comes on the peak of this projectile motion here, this point known as range, this point known as range, defined as range. So this is the A point, this is B point, this one is O point. When the particle comes at the peak point, initial velocity on the y-axis becomes 0 and the ux becomes cos theta, u cos theta. When the particles moving towards Earth's surface, particle comes here and its x-axis ux is equal to u cos theta and uy becomes minus u sin theta. Minus, there is a sign, changing a sign, it becomes positive to negative, minus u sin theta, minus u sin theta. See, this is the projectile motion. A object thrown and project into the air, subject to only the acceleration of gravity. The object is called as projectile and its path is called as trajectory. So total time of flight or total time of flight here, total time of flight, there is a little formulas. Total time of flight 2u sin theta, 2u sin theta upon g. If they ask what is horizontal range, what is horizontal range? Horizontal range is equal to u square sin theta upon g. And what is equation of trajectory? What is equation of trajectory? Equation of trajectory, this is tan theta, x tan theta is equal to minus gx square upon 2u square cos square theta. Clear? The equation of trajectory in the projectile motion, and it proves that the projectile motion is always parabolic in nature. Projectile motion always in parabolic in nature. Parabolic in nature, right? What is? What is total time of flight? Total time taken by the projectile, total time taken by the particle, total time taken by the particle from point O to B is called time of flight, is called time of flight, right? So comes to the next topic. So here giving the short lines for time of flight: total time for which the projectile or body is in the motion, maximum height, maximum value of vertical displacement of projectile or body during its motion. What is range? Range, horizontal displacement of projectile or body during its motion. Circular motion, what? Circular motion in which a body moves along a circular path, moves along a circular path. Okay, we are we first study one dimensional called as linear motion, where particle move from one place to another in a straight line. When we comes in the two dimensional, we read about projectile motion, and we come the circular motion. It is a rotatory motion, also known as rotatory motion, in the motion that occurs when a body revolves around on its axis, rotates on its axis, sorry, not revolve, rotates on its axis. Best example, all the planets in the solar system, all the planets in the solar system rotates on its axis, and they also revolve around the sun, they also revolve around the sun. Clear? So this is the circular motion. And example, they given an example, motion of planets, or what you gave an another example, that is when you driving in the car, when you drive in the car, wheels, there are also wheels in the car. So while driving a car, the motion of wheels and the steering about its own axis. Clear? Car and wheel and its steering rotates on its axis, right? Three-dimensional. Next type comes three-dimensional: motion of water molecules and motion of butterfly in garden. Motion of water molecules, motion of butterfly in garden. This is the example of three-dimensional. But the question arises, what is three-dimensional motion? If all the three coordinates specifying the position of object changes with respect to time, then the motion object is called as 3D. Clear? When all the three coordinates, all the three coordinates specifying the position of object with respect to time taken, the motion of an object is known as 3D, is known as 3D. There are many examples you have taken from your daily life, like motion of water molecules, motion of butterfly in the garden, bird, a bird fly in the sky, a bird fly in the sky, also a kite fly in the sky, also a kite fly in the sky. And the another example is the flight of feather in the wind, the flight of feather in the wind. Clear? All the examples of three-dimensional. Now the next subtopic comes equation of motion. Equation of motion. So for this equation of motion, first we have to understand the VT graph. What is the VT graph? Let's study about this graph. We have but here we have equation of motion. First, V is equal to U plus AT, S is equal to UT plus half AT square, V square is equal to U2 plus 2AS. All three are equation of motion. So The topic is equation of motion and its application. First, we have to understand the VT graph and what is the equation of motion. Motion is represented in terms of displacement, distance, velocity, acceleration, speed, and time. Right? Motion is represented in terms of acceleration, speed, velocity, distance, displacement, and time. These are the terms defined by motion. And now let's discuss about the graph called as VT graph. This is velocity, time, and here is 0 point. This is from u. This is initial velocity, and v denotes final velocity. So when from u point, when particle goes straight line on the x-axis and the y-axis, and we match all the lines, we have like this trapezium. We have like this trapezium form, or a triangular form, right? On the u point, there is an angle made by theta. Angle is theta. So for the first equation of motion, it relates velocity. When we are talking about first equation of motion, it relates with velocity, acceleration, time. All right. So here tan theta, the angle make here theta, it is tan theta is equal to xy upon uy. This is the first equation. From the second equation, what we get, tan theta is equal to v minus u upon uy, time. And here we got our first equation of motion. First equation of motion. How? Now the question comes here, what is tan theta? Tan theta is nothing but a slope. And VT graph represent acceleration. So v is equal to u plus at. This is the final equation, and v stand for final velocity, u stand for initial velocity, a stand for acceleration, and t stand for time taken. This one is the first equation of motion. Now let's talk about second equation of motion. Second equation of motion. Am I audible and visible to all of you? Everyone? Yes? All right. Now comes to the second equation of motion. It relates displacement, velocity, acceleration, and time. When we solve the second equation of motion, the area under the VT graph, the area under the VT graph, let's draw here a roughly VT graph, VU, and this is time. All right, this is the VT graph. Represents the displacement of body. What is represent? Displacement of body. Displacement of body, and displacement denotes by S. Right? What is displacement? Displacement is equal to area of trapezium. Area of trapezium. S. Displacements denote by S. Area 1/2 into 1/2 into sum of parallel sides into height. Sum of parallel sides into height. Right? So 1/2. So here sum of parallel sides are V plus U into V plus U into height, it's T. So the second equation of motion is S is equal to half into S is equal to U plus half into UT plus half into ET square, AT square, AT square, AT square. This is the second equation of motion. This is the second equation of motion. Now comes the third equation of motion. What is the third equation of motion? This equation of motion also defined by VT graph, and it relates. Third equation of motion relates to velocity, displacement, acceleration. S is equal to 1/2. In the second equation of motion, S is equal to 1/2 into V plus U into T. Here S is equal to 1/T into V plus U, and on the place of T, in the place of T, we have taken here V minus U upon A, right? Upon A. What is acceleration? Acceleration formula is equal to V minus U upon T, and its unit is meter per second square, and acceleration unit is meter per second square. So in the T, in the place of T, we have put this value, we have put this value. Clear? So what we get, divide this, all this equation divided, S is equal to, so here we get S is equal to V square minus U square upon 2AS. So V square minus V square equal to U square plus 2AS. This is the third equation of motion. This is the third equation of motion. All right. This is the third equation of motion. Clear? So come to our first slide, equation of motion. So we have given here three equation of motion, and we have really discussed all these equations. How do we get these equations? Get by VT graph. Now comes to the next point. Let's start another subtopic of this mechanics chapter, which is Newton's law of motion. Newton's law of motion given by Isaac Newton. Isaac Newton. First law given here law of inertia. First law says if any object or any body or any particles having a state of rest, it is still in the rest, on the rest, until or unless there external force applied on it, right? It is also called as law of inertia. First law, also known as law of inertia, right? Everybody retains its state of rest or state of everybody retains its state of rest or state of motion along a straight line until an external force applied on it. There are some examples also given here. So, the Newton's first law, the relation between the force acting on a body and the motion of the body, right? So, here are some examples. When a bus stops suddenly, a passenger standing in it lean forward, book on the table stays in a place. All these are the examples of first law of motion, or you should say law of inertia. Also, we are adding here some examples to understand in a very easy manner, like one's body movement to the side when a car makes a sharp turn. You experience this while you in a car. When were you in a car drive, you experience this thing, that one's body movement to the side when a car's taking a sharp turn, and a ball rolling down till continue to roll unless friction or another force stops it, right? So also these are the examples of law of inertia. When we are talking about inertia, is divided into three parts. So all these parts are given here: inertia of direction, inertia of rest, and inertia of motion. What is inertia of direction? Says when the resistance is offered by the body to continue the motion in the same direction unless and on external. That means resist the change in direction of its motion. Example, when the string breaks, the stone tied to it moves in a linear direction. See, when were when were you a child, and in our childhood we all played a lot of games, a different types of game in our neighborhood, in our society. There are a lot of types of game, different types of games. So some people are playing cricket, some people are playing, little things. So there's one thing, you maybe some of you have played this thing, that you taken a piece of a stone, tied it with a string very tightly, and swing it like in the sky, like in a world. And when the string tears or break, the stone will fly away in the tangential direction, right? Now, talking about inertia of rest, resist the change in a state of its rest. If some body or some particle having a state of rest, it resists the change. It do not want to change its state. Clear? So, its example, fruits get detached from the tree when the tree is shaken. Also, leaves get detached from the trees when the tree is shaken. Or also, when a train suddenly starts moving towards the passenger standing in the compartment tends to fall backward. This is another example of inertia of rest. Also, you can say it when bodies move. Also, you can say it. You have also taken the example of Bus. When a bus stops suddenly, or when a bus starts suddenly, your body, your whole body at rest, unless external flow force applied on it. Right? Yes. Now, come to the next, inertia of motion. It resists the change in its state of uniform motion. Example, rider falling forward due to sudden stop. Inertia of motion. When we are talking about inertia of motion, the body continue to be in the uniform motion unless an external force act on it. What are the examples of it? Rider falling forward due to sudden stop, or you should say due to inertia. Artificial satellite keep moving on a circular motion. Right here. Artificial satellite keep moving on a circular path. You can also take another example, falling forward in transport when sudden brake are applied. Comes to the second law of motion, rate of change of momentum. Rate of change of momentum. So the second law is also known as rate of change of momentum, or you could say it is F is equal to ma. F is equal to ma. So anybody who wants to prepare, who are interested to clarify or qualify the UPSC prelims exam or state PCS exam, they must have purchased the prelims possible by Arihant. If you do not subscribe the channel yet, please subscribe the channel and also share this class to your relatives and your friends who are going to prepare for the prelims examination, upcoming examination, and the state PCS, and who want to qualify their exam in the first attempt. Right. Second law of motion, talking about the acceleration of an object, is dependent upon two variables: the net force acting upon the object and the mass of the object. Clear? Rate of change of moment. The force acting on an object is directly proportional to the rate of change of moment. It means, what does it mean? It means when mass increases, force also increases. If force decreases, mass is also decreases. Why? Because they both are directly proportional to each other. Clear? Example, let's take an example. A cricket player lowers his hands while catching a ball. Bogies of a train are provided with buffers to avoid severe jerks. Comes to the third law of motion. Also known as law of action and reaction. That means to every action, there is equal and opposite reaction. Examples, let's take a new fresh example, like during swimming. During swimming, a swimmers move ahead. During swimming, a swimmers move ahead while walking. Also you can say it while walking. This is a very daily life example. While walking, while swimming, and recoil of a gun, motion of a rocket. Those are the examples of third law of motion. Right? Now, comes to the first question. Statics is related to which of the following? Statics is related to which of the following? Option number A, state of motion, state of mind, study of date, state of rest. So the correct answer will be, state of rest. State of rest. Statics. Statics is related to the state of rest. Statics is the branch of mechanics that deals with the bodies at rest. State of motion refers to an object's velocity and direction. Study of date often referred to as chronology or dating methods. Clear? Now comes to the next question. Static science is associated with dynamic situation, situation of rest, mental situation, and data analyzing. So the correct answer will be option number B, situation of rest. Static science is a branch of mechanics associated with situation of rest. Static science examines the equilibrium forces acting on objects to determine their stability and is crucial in designing structures, bridges, and mechanical system. All right. So, aspirants, I think today's theory class is enough for the today now. Right. So after maybe there's a break for a holy festival. So after holy break, we will continue our class with the question answer of this first chapter of mechanics, second unit of physics, motion and Newton's law of motion. Right. So if you do not have this book for your preparation, you must purchase this book, Prelims Possible by Arihant, and also you can recommend this books for those aspirants who are really serious about their examination, about their career, about their preparation. So you can suggest this book because this book really having a good content, amazing explanation, and you experienced a very good, you experienced a very good things with this, and you get selected in your upcoming exams. So after holy break, we will continue the class. Till then, thank you so much. Bye bye everyone, and happy Holi.